It's pretty amazing. 20 watts of power, right? It's about a third of a light bulb, right? And it can do amazing things. It can write symphonies, it can do poetry, it can explore the fundamental forces of the universe. But it has a set of biological constraints. And these constraints are in the neural architecture of the brain that we just can't change. And these constraints are things like how fast we can process information, how quickly we can make decisions, how many dimensions we can navigate in, and just the length of the short-term working memory. Now, because we have these limitations, it opens up a gap in the intellectual ecosystem. And that gap in the intellectual ecosystem is rapidly being filled by machines, and particularly artificial intelligence. Now, with artificial intelligence, we've heard a lot about what it's going to do and where it's going to go and so on. I think the biggest thing it's going to have an impact on, before we get to superintelligence, before we get to any of that, the biggest thing you're going to see with artificial intelligence is it's going to be impact on defense. And the reason for that, you have to understand, is a concept known as an offset. So an offset is a military term that says a set of technological capabilities so advanced that it gives whoever wields them an advantage so large that the opponent without the technology is considered defeated before the conflict even starts. Now, to go through, there's been a few of these over the last century, and one that we'll be familiar with is obviously the nuclear weapon. Nuclear weapon, for those that had it, basically, if you didn't have a nuclear weapon and you decided to attack a country that did have a nuclear weapon, you were assured of destruction. And so as a result of that, you had a technological offset that ensured that you never had attacks between non-nuclear powers and nuclear powers. The second one, which perhaps doesn't get as much understanding, but I think is equally significant, is this combination of stealth weaponry and precision-guided munitions. Now, to kind of understand this, the US obviously developed these technologies and deployed them for the first time in Iraq in the first Gulf War. Now, to get a context of that, we forget this a little bit, but the US was the strongest military in the world at the time, but the Iraqi military actually was the sixth strongest military, and we forget that. And the reason we forget that was because the war was over effectively before it started. 96 hours after war was declared, the war was over. And it gives you a sense, again, that if you have a technological offset, again, if you do not have that, the war is over before it even starts. The third one of these that we're coming into now is the age of artificial intelligence. And I would argue that artificial intelligence is going to be a bigger impact on defense than those other two ones combined. And the reason for this is it's not just something that empowers and enables the kinetic side of conflict, it also changes the entire cognitive side of that conflict as well. If machines can outthink you, they can outplan you, they can outstrategize you, as well as outmaneuver you on the battlefield. So this is not something that's kind of science fiction. This is something we're seeing today. We're seeing this in the conflict in Ukraine. You're seeing the first kinds of artificial intelligence being deployed inside of war zones. This is an example of a loitering munition. You can see it there, but you can also see it's got basic object detection and image recognition embedded inside of this. Seeing this first kind of idea that it will loiter up, look for a target, and when it sees it, it'll dive down and destroy it. Now, the accuracy and the efficiency of these things leave a lot to be desired, but I think what's very interesting is you're seeing this now today. You're also seeing these platforms upon which these things are being built. This is an example of a USV, an unmanned surface vessel, a boat, effectively a modified jet ski that the Ukrainians have built and are deploying to great effect, deploying to so much great effect that effectively the Ukrainians without a navy have wiped out the major extent of the entire Russian Black Sea fleet, doing things like this. This is live first-person vision from a USV, and you'll see it going through and targeting a traditional, conventional warship. You can also see the danger that the Russians know that this poses to that threat, and you'll see the bullets starting to come in to try and destroy it. And again, it's being driven and navigated through. No artificial intelligence in this at the moment, but of course it is a platform on which top you can put artificial intelligence in, and that is starting to be experiments that are being run. But you're also seeing this in the air. You're seeing USVs, and particularly you're seeing USVs attack other USVs. And so you're getting drones coming in now and trying to attack the sea drones. So you've got drone v drone warfare unfolding in the battlefield. And you're also getting the ability to navigate into previously hidden spaces, going through, taking the USV and looking for, in this case, in this scenario, a big munitions cache and going in and trying to destroy that. So effectively like a computer game driving through and navigating these environments. Again, this is all done with first-person vision. It's all human-controlled. There's no artificial intelligence in this. But the next generation is going to have artificial intelligence capabilities. And we're starting to see that now. Now, the US put together this challenge, right? They put together this challenge. I don't know if you're familiar with AlphaDog. AlphaDog was put together by DARPA. It was a competition that basically said, we're going to have the best Top Gun pilot in the US Army is going to fly against the best computer simulations, the best AI systems. And we're going to run a competition to see who's the best. And so they set it up, and this is classic DARPA stuff. AlphaDog fight, human versus machines, phase 1, phase 2, phase 3. So they did the competition with a sense of taking through and actually putting it into planes. And they ran it through, this is all in simulation, and they put together 8 AI teams to compete with each other to see who was going to be the victor, who was going to take on the best human. And the AI teams worked together to compete against each other, and there were some really interesting teams from Lockheed Martin, some big universities. But what was interesting is a team with just really 3 or 4 people using reinforcement learning ended up winning. So Heron AI was the winning artificial intelligence company, and they earned the right to take on the best Top Gun. So they took this on and they set up the challenge and they set it up a simulation. They put the pilot into a VR simulation with goggles, navigating around. You can kind of start to see the dogfights that are unfolding. There's the pilot navigating against this. And again, they're going into a head-to-head battle to see who's the best pilot. Now, what was interesting about this was that it wasn't even close. The AI system, again, this was a team of 3 or 4 people, not a big organization, took on and trained a reinforcement learning model that was able to beat the best pilot in the US Air Force 5-0. And they were able to do that because it learned tactics that the human wasn't prepared to take on. They were going to take risks that the human wouldn't do. They were going to take decisions much faster than the human brain could process. But this is very significant, right? In simulations today, the best pilot is not a human, it's a machine. And it's a machine from a company of 3 or 4 people. So they actually took this on and actually took it from sim to reality. This is currently going on. They're putting this into one of these modified F-16s. You can see the modified F-16 on the left. That is being flown now in the US by these same artificial intelligence systems. And they're actually conducting live dogfight trials. And they're running this now, and it's kind of crazy, right? You've got the pilot flying against another machine and actually trying this stuff out. Now, they haven't been as forthcoming in the results of this experiment, but at least the rumors, if that to be believed, is that the artificial intelligence is again besting the best human pilots. So really, really significant advance here, and this is being run through Alpha Dogfight. But this is all single-player stuff, right? This is all 1v1, right? The interesting stuff in games and in conflict as well is multiplayer. Now, the multiplayer, for those that are computer game players, you may know Dota. For those that don't know Dota, you may know StarCraft, maybe. But Dota is a fantastic game, multiplayer, incredibly complex. And it's got a really interesting connection into artificial intelligence. And the reason for that is to give you a sense of the game of Dota versus chess, much more complex. But to kind of get an understanding of it, in Dota, you've got a fog of war. In chess, you've got perfect information. 80 moves is about how long a game of chess takes. You've got 20,000 moves in a game of Dota. It's got discrete actions versus about 20 per second. And it's really high dimensional. You have about 8,000 options at any time. So incredibly complex game. And you can kind of get a sense of the game here with sort of game complexity as it moves, right? You've got tic-tac-toe, all the way. It was solved in 1952. Connect 4 in 1995. You've got chess was solved in 97. And Dota was one of these, incredibly complex, 10 to the power of 1,685 possible moves, which gives you a sense of how much more complex it is than even Go. So that hadn't been solved, right? So the OpenAI team put together a challenge to try and go and solve this. And you can kind of see some of the inputs to their reinforcement learning model. You can see the progress of the performance of that team. But ultimately, they think they got their system good enough to take on some of the best teams in the world. So again, they ran this competition, best human team of Dota in the world versus artificial intelligence. And again, spoiler alert, it wasn't even close, right? 5-0, OpenAI won. So we know OpenAI now, of course, with ChatGPT and the rest of it, but this is actually where they cut their teeth in a lot of their artificial intelligence work. And so what's interesting as this starts to emerge is this kind of concept of multiplayer dynamics coming together, increasing the complexity of the state space you're operating in, increasing the tactical complexity and the strategic complexity. And you get to this thing called swarm dynamics, right? Or in Chinese, drone swarms. China being very good at doing this. This is a set of what I like to call Chinese real military parade. Navigating through, they've got about 10,000 of these can fly simultaneously. They seem to be doubling that every about 12 months. This is all controlled. It's not autonomous. It's not using a lot of AI, but it is a real flex saying we can get 20,000 objects flying in close proximity with a lot of comm structures. And yeah, we could put some kinetic warfare components on top of these if we so choose. You can also see in a much more militaristic basis here. You can see this stuff and going through. You can also kind of see the official doctrine of the Chinese CCP military. But again, like the reality is now, the Chinese and indeed the US are planning and testing and moving tens of thousands of drones to operate inside of large-scale swarms. So this is being battle tested. You're seeing the first kind of drone swarm dynamics come through. I think those will be familiar a little bit with Operation Spiderweb. If you're not, I think it's probably one of the best operations. It came just after Zelensky met with Trump, and Trump said, "You hold no cards." And a week later, this was the card that was played. But basically, a couple of shipping crates disguised as small houses, hosting 36 drones in each container, armed with about half a kilo of explosives, went out and were shipped in via the truck deep into Russia to go and attack their nuclear-capable planes. And they went in, and you can see them on the attack here, launching out of the containers and going out and flying towards the nuclear bombers. And again, estimate here, the cost of this operation was in the single-digit millions. The cost to the Russians on this was in the hundreds of millions, if not billions, of dollars. So massive asymmetric advantage when you start putting this together. But again, it's all first-person vision. Now, what was interesting was there was a fail-safe AI component for the last mile of this, that it was trained on images of these bombers, and that if the connection to the human operator did fail, it was designed to kind of try and target. How well that would have worked, we don't know. But you're getting into this dynamic of, well, all right, you are in GPS-denied environments, you're in comms-denied environments. These things really have to be able to fly themselves. So where are we on that? Where are we with AI control of these systems? Well, there's a really interesting another game. You'll see the theme here. This is Drone Racing League. I don't know if there are any Drone Racing League fans, but this is on ESPN, and I assure you it's a real thing. You fly these drones around these big stadium courses, and people compete to be the fastest through all of these different barriers, loops, and gates. So, of course, machines had to take this on. It's all physics at some level. Yeah, there are turbulent mechanics and turbulent dynamics and the rest of it, but it's kind of all physics. And it turns out that a team out of ETH Zurich was able to solve this, published on the cover of Nature, Science Robotics, and they were able to train a reinforcement learning model with extremely low latency to navigate through these systems and do it better than a human. So you can see the pathways there that the AI has used versus the ones that the humans have used, but it's kind of cool to see it running live. So again, running through it, you notice the incredibly high velocity that they're moving these systems through. They're getting up to about 30 meters a second as they navigate through this. And some really interesting machine learning to deal with latency, updating of the models, and also dealing with turbulent mechanics through disturbed airflow. But I think what was most kind of crazy about this is the speed at which this worked. If you look back at 2016, you can see there, the maximum speed that these things could operate and safely navigate through was about 0.5 meter per second. And within 6 years, they were going at superhuman speeds of 30 meters a second. And of course, it doesn't take a genius to kind of see the capability of doing that. Back to the previous video that we just saw, and actually taking the AI system to navigate and automate these systems through. But again, this is all single player. Multiplayer, again, it gets a lot more interesting, and this is where China has been investing a lot of its R&D, and if you look at a lot of the research universities there, multi-drone swarm coordination, autonomously tracking and moving. This is a paper that was published for tracking an object through multiple drones with occlusion. You can get a bit more of a sense of that. So it allows you to navigate through very complex forest-like environments where information is being shared between each different drone so that each drone is able to kind of make use of the collective intelligence of the other drones that are capable within it. Again, very, very effective way of navigating through dense environments. But you can also see it for tracking and targeting an object. So the different drones are able to kind of do that. And if one drone loses it, another drone is able to find it. And if this is kind of a little bit kind of scary, yeah, it is. So this, I think, is perhaps going to be closer to the kind of image of what we might think about for future air-based conflict. This is a set of starlings that are flocking over a field in England, but you could very equally see tens of thousands of drones going in and fighting each other. Or here, you've got reef sharks navigating through schools of fish. But again, they could be drones moving and attacking other drones. So these biological systems start to become better metaphors, I think, of what war is going to start to look like in the kinetic dynamic of thousands of unmanned systems fighting against each other. But it's not just in the kinetic, it's also the strategic. And it turns out that AI is very, very good at strategic manipulation. There was another game came through here. This one really flew under the radar a little bit. This is a team out of Facebook, which was kind of a surprise, but well done, Facebook. This is a game called Diplomacy, and if you haven't, I don't know if anyone's played Diplomacy. It's very, very popular in Washington, D.C., but basically, the goal is to create alliances with your friends and then stab them in the back, which, you know, maybe is an explanation of why it's so popular in DC. But it is games that go on for, you know, all day, and it's incredibly complex. You have to get people to trust you, and then you have to cheat on them. And you form alliances, and then you break them. Well, it turns out in about 2022, Facebook trained a model, and they trained it. This is pre-Instruct GPT, Chat GPT. So they trained a really primitive model, and it bested 90% of the best human players, right? To get a concept that the AI model was able to better navigate and automate a strategy to take over the world and then convince people to join it and then stab them in the back than any human was. And again, if that doesn't worry you, you know, you're probably thinking about it wrong. And a lot of people at this point want to hit the sort of the stop button and say, can we just stop this? Can we stop the developments? Can we regulate it? We did it with nuclear weapons. Can we just stop this AI coming and encroaching into the world of conflict? And sort of the answer on this is it's kind of, this is not enriched uranium, right? This is mathematics. And there are ways to kind of think about, you know, getting an advantage in this, but it's incredibly hard to centrally control this. So I think we have to accept that this is going to be part of our world, and indeed it's going to be part of the battlefield. And it's going to be very hard to stop it. So, like the Red Queen having to run faster just to keep up, the race is on. And the race, I'm sorry, Europe, it really is between China and the US. Unclear what the relationship between Europe and the US is going to be in this dynamic, but certainly the relationship between the US and China are clear. And if you look at the two global superpowers, these are the two global superpowers. So how should we measure their performance? How should we measure where they're at? Well, I contend that there are 4 bits that we should look at when we start to think about this AI arms race: who's winning and who's ultimately going to win. And the first of these is algorithms, the second is data and labeling, the third is compute, and the final piece is the deployment of it. So if we look first at algorithms, algorithms are the lifeblood that give the intelligence to these systems. They're the mathematics behind it. They are ultimately the brains of the system. And if you look at this, you can see here, this is the percent share of the top 1% of papers cited. So this is not the total number of papers, this is the top 1%, the creme de la creme of AI research. The United States has always enjoyed that lead. 2024, the numbers just come in, China has bested the US. Just to be clear, the top 1% of all papers that are cited, China has more of them now than the US. And they were a long way away as early as 2015. US still holds the lead in terms of deployment. This is a GitHub stars or a proxy for usage of these algorithms. So US algorithms, although they're not being cited as much, they are still being used quite a lot more. You can see the EU in there has actually got a fair amount of usage of the models. But China is considerably behind the United States when it comes to use of models. But the kind of places where they are putting their research, if you look at it, it's pretty obvious that it has very strong military applications. So China, if you take computer vision, navigation, and complex uncertain environments with visual models, the top 5 of the top 6 are all Chinese models, right? And so China has made a very concerted effort to orientate its research universities around applications that are much more specific towards the defense problem space. So things like computer vision, surveillance, industrial applications. The US has been leading in transformers and LLMs, it's also been leading in reinforcement learning, and also doing a lot more in AI ethics and safety. But you're also seeing the second component here, which is the rise of open source. And the open source component is something that China's really embraced. A lot of the models that come out of China are open source. As you're seeing the rise of that, so there's an interesting kind of question, right? You may have the best research, you may have the best research teams, but if it's all open source, does it even give anyone an advantage? If you can just download it, deploy it inside of your system, does it give anyone an advantage? So this kind of push towards open source is effectively a way of neutralizing some of that deployment advantage that the US has. A lot of attention focused here on China coming through with DeepSeek. I think probably half the world heard this. Certainly the financial markets heard it. There was a $600 billion loss on the day this came out. The announcement from DeepSeek has a new model. It's very, very good. I don't think anyone went in and actually looked at the paper, but maybe they should have. It was interesting, right? Actually really nice kind of breakthrough on GRPO, which is a type of policy optimization. Nice gain. But what the world missed on this was that these gains have been happening all the time. You expect the performance and the efficiency of these models to increase over time, and this was a nice step on that journey. But it was no more unusual than anything else that had been happening. So if you take an example here, this is the classic ImageNet model, and when it was put out with AlexNet to when it is today, we've got 44 times less compute to train the model. So actually, we're getting better at training these models over time, and actually it's outpacing Moore's law. And it's something we forget about. We think a lot about chips, we think a lot about the speed of the chips that are performing, but we don't think a lot about the algorithmic efficiency. But we've been getting better at algorithmic efficiency, and DeepSeek was but one more step along that way. So I think with all that in mind, I think on balance, you have to give this to America at this point. But I think if you came back to me in 12 months, it's not clear which side of that we're going to land on. And certainly that race is tightening. If we look at the second piece of this, the labeling to train, to fine-tune, to get the model to perform the kinds of tasks that we want. China has a huge data advantage. But it's not just data, of course, that allows you to do this. Tracking cars, identifying people, not quite the same as identifying nuclear submarine acoustic signatures. So you have to actually go from data collection to data labeling, and turns out data labeling has a whole bunch of humans labeling data. China is very good at this. They actually have around 3 million people labeling data today, and they're doing it for about $400 a month, which is about 10 times cheaper than what the US can do. Huge kind of hidden industry behind all of the models that we're using is the people sitting down and telling the computer what they know. But of course, once you've got models that can detect things, you're going to have models that try and deceive it. I really like this example here. This is a face detection model, and it's being fooled here by putting on a sweater that's designed to break it. So really interesting kind of cat and mouse game going on where people have algorithms that do one thing, and then people try and avoid the algorithm that does it. I don't know if you'd actually wear that sweater anywhere, but it's kind of fun as it goes. So you're going to get this competitive dynamic of these things moving. So on that, the labeling very clearly goes to China. So we're at 1-1 on that journey. The compute's an interesting one, and it's had a lot of attention. The computers, of course, the GPUs, the data centers, the power that goes into them. And the reason for that, as you can see another graph here, is just the amount of compute that's required to train these models. This is a log graph on the left, so you're going up a long way, and you can kind of see the initial AlexNet model had less than 1,000 petaflop days of training, all the way up now to 100 billion on the side. So massive kind of increase in power. And of course, the next generation models are going to go and continue up that train. So what's underneath that, of course, is a lot of chips. China imports more dollars worth of chips than it does of oil. $430 billion of chips in 2021, only $229 billion of oil. China is a massive importer of computer chips. And that's important, right, when you look at defense, because if you take a thing like this Javelin missile launcher, it has 200 semiconductors inside of it. If any one of those semiconductors is not made, this isn't made. So you have to control the chips in the same way as you don't go to war if you don't control your energy sources. You don't go to war if you don't control your chip sources. And China doesn't control its chip sources. So 95% of the advanced chips that China produces are produced by foreign countries, and they're produced by countries that are from these regions: Taiwan, Korea, and other global foundries. But you'll notice Taiwan. And Taiwan produces, indeed, 92% of all the advanced AI chips in the world from a little company called Taiwan Semiconductor Corporation, TSMC. And 92% is on that little island that China would consider part of its territory. And China very much wants that. And to give you a sense of how much it wants that, Taiwan controls 92% of all the advanced chips. OPEC controls only 38% of the world's oil supply. So there's an incredible concentration of chips in this one island off the coast of China, an island that China believes is its. And so you end up in a place where we've fought many wars for oil. We're going to start thinking about fighting wars for chips. And so the US is preparing for this. It's bringing and saying, well, we aren't confident that Taiwan is going to be something that we can rely on for chips, so we're going to try and onshore them. And you can onshore the fabrication of chips. It just takes hundreds of billions of dollars, and it probably takes about 20 years. This is not something that happens overnight. And the reason, these things are incredibly complex are things like ASML. ASML is a Dutch company. It's part of a consortium it's part of a consortium of companies that supply parts to TSMC. But this is the ultra-high wavelength lithography that puts the etching into 2 nanometer substrates on chips. And they only make a few dozen of these every year, and they're the only people that make them. And to give you a sense of the complexity of that, just one laser in this system has 150,000 components. It's incredibly complex to make, and you need these to make the really small chips. And so the supply chains and the control of those supply chains become very important. And the United States, provided it maintains its relationship with Taiwan, is very much in the lead in this AI arms race. But you would flip that in an instant if China were to take control of Taiwan. So if you think about this, yeah, the algorithms, they're important. Yes, that race is tightening up. The US has a massive lead in terms of its ability to control and access the most complex advanced chips in the world, and China very much has its eyes set on this, because you can't win in the global geopolitical landscape, either economically or militarily, if you don't have control of the chips, and China doesn't. But with one island, it would. So the final bit of this is into the world of deployment, right? It's all well and good if you've got your chips, you've got your algorithms, you've got your compute. But if you haven't put it into the system, for what value is it? And so this is about speed of procurement. How fast can you get the technologies that are produced into the hands of your soldiers, and how fast can you make use of that on the battlefield? So to give a sense of this, in the old world, this is the F-35 Joint Strike Fighter. It was delayed. It was delayed many years. It was delayed for several years because the heads-up vision interface on the helmet wasn't quite syncing properly with the F-35's computer systems. So that delayed it for about 5 years. And again, 5 years in the world of that, where you're the dominant military and things aren't moving that quickly, not a big deal. But 5 years in the world of AI takes us from this world. I keep thinking, that was 2015. He's almost, no. And if we fast forward to today, that's currently state of the art in China. That's just crazy. That's 10 years of development for mechanical motion of bipedal humanoid robots. Of course, things have sped up, right? So if the US doesn't move, it gets left behind. And it's got a real problem in terms of procurement inside of the very, very large bureaucracy of the Department of Defense. And it has to solve that because this is how fast the opponent's technology is moving. China has this concept of military-civil fusion. There's no separation between what you're doing commercially and what you're doing for the military. If it's important for the military, we will have an interest in it. We will have a board member in it. We will have a controlling stake in it. And that allows them to kind of create games like this. This is Chinese robot games, building real robots, basically going first-person vision shooting. And you can kind of see what they're training for here. You go back to the videos from the start about Ukraine. There's first-person vision, shooting in, trying to take them out, control systems, navigation systems. The integration of this into the very culture of the country is very, very clear. And of course, in the US, we come from a world where literally when Google decided it wanted to work on a Department of Defense Project Maven, which was the first AI deployment inside the Department of Defense, Google literally had protests and people walking out and saying, if you do any work for the Defense Department, we will not work here. So a huge issue with the US, and that's being overcome and that's changing, but we're starting very much from a different position. So that work is coming through and there is a lot more work, and Doug Beck here just recently stepped down, but he was leading DIU, did I think some very interesting work, bringing the sort of his experiences at Apple into the Department of Defense. But I would say China is a long way ahead in getting this stuff moving faster and getting it deployed and getting it into the system. So that kind of leaves us at 2-2, right? And if that's kind of, you're saying, well, all right, that's not really an answer, who's ahead? I think it's very, very close. And what we've got here is a global AI arms race, and it's really not clear who's going to win it, but whoever does win it is going to control the military landscape because this is the third technological offset. And anyone who doesn't have this capability will be defeated very, very quickly. But of course, war is not all just about the kinetic side, it's also about the informational side. And if you control the information space, you can control the battle space. And to give a sense again of how fast controlling information space has gone, this was state of the art in 2014 for image generation. 5 years later, that was state of the art. And today, you're able to generate full motion video, basically off of anyone with an account that's around. The speed at which this has moved, the speed at which we've been able to create and shape narratives, to build realistic simulations and visualizations of the world. But what's come through is it's not just good, it's superhuman. Humans find AI generation of faces more trustworthy than actual human faces. And the reason is once you can generate, you can personalize, you can make it specific, you can elicit all the responses just for you. And so when you've got this ability to create and shape a landscape, to manipulate a population, to drive and generate empathy, you hold a lot of power. If you can wield this on a platform, you can control the hearts and minds of entire populations. It's good that China doesn't have a platform that does that. We're very lucky. But of course they do. And the US has finally gotten itself to a place of realizing that perhaps having your opponent, future war opponent, controlling the entire media landscape for everyone under the age of 40 and everyone in your military may not, in fact, be a good thing. And we'll see if it actually goes through, but the US will take back control of this because they finally realized that putting that into the hands of their opponent was not a good idea. But make no mistake, you can influence and move and change populations if you have artificial intelligence and you have a platform to deploy it on. And I'll leave you with this final quote from Sun Tzu. Those who win every battle are not really skilled. Those who render others' armies helpless without fighting are best of all. And so for China, its goal is not to bomb Taiwan into oblivion, it's to convince us that we should never fight for it in the first place, to take it back as though it was always China's, and to say there are better things for us to worry about. But make no mistake, whoever controls Taiwan and controls the chips will control the economic and the military landscapes and the world that we live in. War is coming. And whoever wins the AI part of the battle has a good chance of winning that conflict. On that cheery note, I'll let you go. Thank you.